So yeah, going back to like our string examples, again, string is another fundamental data type that is like brought together. And in order to declare and use variables of this type, the program needs to include the header, where the type is defined with the standard library of header string. So again, this is just our header. So all it's saying here is that if you want to create a string like this, where we say string, my string, semicolon, you must set my string equal to whatever string you want. And this like preprocessor definition has to be included in order for you to even use it in the first place. So when you're running your main function and then you write out this is like my string, you have to make sure to write out like this is a string basically. And when you're putting that within quotation marks, that's what lets your computer realize that you have a string in the first place. So again, we'll come back to this example, but I just want to talk about a little bit more about what strings are. So strings can be initialized with any valid string literal, just like numerical type variables can be initialized to any valid numerical literal. All this means is that like there are different ways that you can define a string. So like these are the different ways that are possible for you and available for you to create a string. All of these are completely valid. Again, just like pick one of these. If you remember, this is like our C-like initialization. This is something that we talked about before. This is just our C++ like next generation initialization. And again, all of these mean the same exact thing. You just get to choose for yourself which one you want to use. So what can you actually do with the string? So strings allow you to do like many things because it is a class and it's not just like a variable type. So for example, you can actually find the size of your string. You can get a specific character from your string. You can append strings together. So you can basically connect two strings together. You can also swap strings. You can exchange the values that two strings have. You can find a substring, so basically a part of a word inside the rest of the word. And you can even insert parts into other parts. And so you guys are going to have practice examples of all of these. I just want you guys to know that like you can do so much with a string in the first place. And yeah, so what I want you guys to do is first, now that's basically kind of all we have for strings. So we're going to go and create our first string example. It'll look like this. So you have like your class, again, your IO stream, but you will be including a string, okay? The string class. So again, this is another preprocessor definition. Then you'll be writing out string, my string. This is just the name of your string. So you can say like string name, for example. And yeah, actually what I want you to do is write this out. And in these quotes, write out what your name is. So I'm writing Malishan. And then I want you to print out your name to the screen. So try this out. Try out this definition. And then run it. See what happens. You should get out your name that comes out. So again, this Malishan counts as a string variable type. And then create a bunch of other strings for yourself. So create like new strings. And then try doing these functions to it. Try adding them together. Try finding the size of them. Try finding substrings within strings. And if you have any questions about this, let me know. So I'll give you like an example of like the functions. And yes, you should be able to print out the string statement. That's the entire point. And so what you want to do is like, for example, afterwards, what you can do is now like one of the functions, for example, is size, right? So name.size, what I can do is print out that to my screen. And do you see 10? This 10 relates to this, like how many characters in my screen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's what all these dot functions are doing basically. So whatever I described here in the beginning is the purpose of those dot functions. And so what you can do is print out that result to your screen. So I want you guys to like spend some time on that. I'll give you like 2 more minutes basically until 45. And if you have any questions about it, just please let's like send them coming. And I'll show you examples of each. But yeah. So what we're going to be doing is first going over the different types of function statements. So hopefully you got some time to like explore it yourself and try to understand it, kind of like what each function does. And I'm going to be showing here like how you can actually implement it. So I'm going to say this is endl. So again, guys, do not get confused just because I'm writing endl. All we're saying is we're going to put it into another line. Okay. So like I said, when I run this code and I write out Malishan, right? This is putting out 10 because this is a dot size function. So dot size is just basically saying what's the size of the string, okay? So if you look at it, we have 1, 2, 3, 5 basically letters in my first name, right? And then it also includes spaces. So it counts this space as 1 letter. And then 4 letters in my last name. So together, this is like 10 letters, and so that's the size of this string. The next thing you can write out is count name dot at. Okay, so what you do here at name dot at is give a number, and then it shows you what the value is of that number. So like for example, if I write 2 and I run this, oh yeah, I print out L. So this is the L. I'm sorry, I don't know why this is confusing. You know what? I better write 1, 2, 3. If I write 4, I should print out Y. See? So the thing that you should know about strings is that the way that it counts is really weird. So we usually count numbers as like, for example, my name, Mally, right? We would usually think that we start from like 1. So position 1 is M, position 2 is A, position 3 is that L, and so on. But in computer code, actually M is position 0. So we always start counting off from 0. So then A is 1, L is 2, the other L is 3, and then Y is 4. So here, when I wrote at 4, what your code is doing is like counting, like, okay, what's the position? What's the letter that exists at 4, basically? What's the character that's there? So it goes like 0, 1, 2, 3, 4. Okay, that's Y, so let me output Y. So that's what that code is doing. So that's the at function. The other function is, like I said, name dot find, okay? And so what find is basically what I was trying to do. It gives you, like, you can put in any letter, any substring, whatever you want, and it will find the position of it. So it's like the opposite of at. So for at, I put a position and it gives a letter. For find, I put a letter and it gives me a position. So here, when I run it again, it will give me Y, or it will give me 4, because Y is at position 4. When I mean substring also, I'm talking about like multiple letters. So what I can do is write it out like this, and if I run this, it'll give me 2. And so a substring is kind of like a string within a string. So actually I'm going to write Allie, because Allie, like you guys might know already, is actually even more common name than Mally. But Allie, like, think of it as like a word within a word. So Allie exists within Mally. And so it first, in order to find that substring, what it does is it looks again through my name and finds the first occurrence of that substring. So again, I have Mally here, and in order to find the substring Allie, we're trying to see like where does Allie first occur in this name. Well, again, we're starting counting from 0, so 0 is M, and then 1 is our A, and then we have 2, 3, 4. So technically, all of this, 1 to 4, that's our index for Allie. But what's actually being like pointed, or what's actually being outputted, is 1, because it just shows the first instance. So where does Allie first occur? At position 1. So hopefully that makes sense, the difference between substrings and characters. So before I had just written out Y, now I'm writing out like a kind of a word within a word. The next one is append. So count name dot append. And what this does, it like adds another word to the word you already have. So if I said Malishan, and I'm going to say like a 12th grader, right? Because I'm going into the 12th grade. And I write this out and I print it. What's going to happen is it's going to append 12th grader to the string Malishan. And you notice like how there's not a space in here, because literally when it's appending, what it's doing is like smushing everything together, like combining it together. There's a space in between 12th and then grader, but there's no space between Shan and 12. And if you want to be like very specific about how you format this, you could just put a space in between, so a space right before 12th grader. And if you run it, now you have a space here. But yeah, all append does is just add a string to another string. Let's go into actually the fun part of what I really want to talk about today, which is inputs and outputs. So, this starts loading. So the example programs of all the previous sections that we had has very little interaction with the user, if any at all. Basically, we haven't asked the user to do anything but just run the program. So again, we just simply printed values onto the screen, but the standard library provides many additional ways to interact with the user. So standard library basically refers to those like hashtag statements that we had before. Those are things that we've been like asking the computer to be adding into their own code. And so we're saying that there's another library available to us to utilize this input-output features. So C++ uses a convenient abstraction called streams. So this is kind of like where we go into the explanation of what the I/O stream is. But again, don't get too bogged down by like what does it mean by abstraction. Just know that streams perform input and output operations. Sorry, there's a question in the chat. But they ask for basically, oh, okay. Again, you guys don't have to write down all of this. If you want to, you can. I'm sharing all these presentation slides at the end of the day. So write down anything you want to, anything you can, and anything you're missing, or you can always just catch up later on. Because again, I'm going to be sharing these slides with you guys. And it's already, like, it's in the same Google Drive that I've already shared with you. Okay, sorry. Again, so C++ uses a convenient abstraction called streams. These perform input and output operations and allows you to look at sequential media. So sequential media is, again, just your screen, your keyboard, and your file. So the way that the computer is even able to read and understand the inputs that you're putting into it is through these streams. So it's an entity where a program can, again, either insert or extract characters to and from. So what it means by this is like every time that you've been outputting basically a string onto your computer, every time you've been asking it to print out something using the count statements or the std count statements, again, those are things like where you're inserting characters onto your screen. Extracting characters is reading off of your screen. And this is what we're going to be doing when we're inputting stuff. So when we're asking the user to like tell us their name, that's going to be extracting the information, like extracting their name. And then when we output like, hi, someone's name, that's going to be you inserting those characters back onto the screen. That's going to be you like outputting that information. So again, streams are a source/destination of the characters, and these characters are provided/accepted sequentially. So this means like one after the other. So every time you put an input, it's going to read the input like up, like top down and left right. So just like how you normally read like a book, or how you normally read like a list and a bunch of statements together. So let's look at some examples. Oops. Okay, so again, the standard library defines a handful of stream objects. So the examples that I'm talking about specifically are cout and cin. These are our input and output streams. So you can think of this out as, again, output, and in as an input. So these are like some examples of other things, like other output streams. So they work exactly like cout. Don't worry much about this line. Like, we're not going to be looking too much into these identity streams, but like if you wanted to know about it, like here's more information. The most important thing is to just understand what cin and cout mean. Again, they're just standard output, standard input streams. So okay, now let's start actually talking about output. So on most program environments, the standard output by default is, again, your screen. And the C++ stream object defines access to it through cout. So for formatting outputs, what we always do, and like what we've always been doing, is actually using these two less than signs. So these two less than sign operators insert the data that follows into it into the stream. So again, this is what we did with hello world. We basically said cout, right, our count statement, and then we did these two insert operations, and we said output the sentence, output hello world, output I'm a C++ programmer, output my age, stuff like that. So we already did these exercises. We've already been doing these things. This last little box here basically tells us that you can do multiple insertions at once. So you guys have been like putting cout into like multiple different lines, but what you can do is chain it together. So by chaining, I mean like combining all these sentences together. So bringing them together so that you have like all of these information together being outputted onto your screen. These show other examples of the cout. So this is what I was talking about today. Specifically, we got like a lot of questions about it. We went over people's programs and saw that this was showing a lot of errors. So again, endl, cout, and endl you can only use when you're using namespace. So if you remember, at the top of our program, even before we write any of our code, we always write using namespace std. That allows us to use cout and endl in order to print the lines, print the results on different lines. So that's basically, if you want to try out this practice problem, it's not really necessary because like, we've been doing it like all of today. But you would notice that if you did this versus if you did this, you'll get entire string. So for example, you get 1, 2, 3. So everything's printed out together, right? Versus 1, 2, 3, where everything is printed out like onto separate lines. That's all this endl, again, allows us to do. But you can only use endl when you're also using namespace. But the thing that's really the meat of today's kind of presentation lecture is the standard input, which is cin. So in most programming environments, the standard input by default is your keyboard. So think about it. Whenever you search up something online, or whenever you're like typing out something to go into like a text file or to like write an email to your friends or something like that, this is always using standard input. So you're putting something into the keyboard, and that's the input that's being taken in. So for formatting input operations, we use 2 greater than signs. So remember with C output, we get used 2 less than signs. But so C output would be like these 2 little signs, while C input is like the opposite. So it's 2 greater than signs. So that's how you basically tell the difference, both by saying C in and then these greater signs, and then C out and less than signs. So this operator is then followed by the variable where the extracted data is stored. So in this case, we defined a variable, like remember, we just talked about like declaring variables, making space for our variables. We say int age, so this is us declaring it. And what we're doing here is that we're saying that we're going to extract the data and store it into age. So extract any data basically from the user. So when the user inputs something into their computer, your computer is going to take that information and store it into that variable age. So the extraction operation on sin uses the type of the variable after this. So the operator determines how it interprets the characters read from the input. So all this means is that for sin, or cin, we always like have to declare what kind of type it is. Remember, we always want to say if it's int, double, boolean, whatever. But we need to first define it and declare it before we can actually put in something to that value. So if it is an integer, again, the format expected is a series of digits. If it's a string, it's a sequence of characters, etc. So it's not just enough to put in cin, because your computer also needs to know what kind of data it's asking for, what kind of data is going to be inputted by the user in the first place. Again, extractions can also be changed to request more than one data in a single statement. So cin is being chained with ab, so it allows us to chain all of these things together. So it allows us to see us putting these things together. So if we want to get both the a and b variables and get the input from both of these variables, then you can chain it together to request like more data on a single statement. So again, this kind of statement is the same thing as this. So you putting it onto 2 different lines versus you putting it on 1 line. So in both cases, the user is expected to introduce 2 values. So not 1, we're asking 2 values for both A and for B. And so any kind of space is used to separate 2 consecutive input operations. And you'll understand what this means. But basically, whenever you're inputting something into your computer, the way that your computer like recognizes that one of them inputs should go to A and the other input should go into B is by having a space in between them. So the space could be like a tab, a new line, whatever, just having a space. So the extraction operator can be used on sin to get strings of characters in the same way as with any other fundamental data type. So that's why we talked about strings just now, because a lot of times whenever you're going to be asking for input from a user, you're going to be asking for multiple sentences or multiple letters or words or whatever. So always like you're using cin in order to ask for more things from the user. And you're going to be using it with strings because strings allows you to actually write in more things. So an important note is that cin always considers spaces, so it considers that as to be the terminating value. So therefore, when extracting a string, you always extract like a single word, not necessarily an entire phrase or sentence, unless of course that phrase or sentence has like no spaces in between it at all. So this goes back to the idea that any kind of space is used to separate between 2 consecutive input operations, because any kind of space also like terminates the value that is being extracted. So for example, if I was going to ask for the user to give me 2 values, one for A and one for B, me as a user would be writing in 5 space 6, so that 5 goes in as A and 6 goes in as B. So that's what that space and that's what this line is kind of explaining, what it means by the terminating value. Then finally, the get line gets an entire line from C in. So this is a function that allows you to take a stream as your first argument. So again, the stream is just your input, and the string variable as your second argument. So you don't really have to worry about this. It's just like talking about what is getLine, but you will see like when you actually try it for yourself what the importance is. So this is your getting input project. So we're actually really good on time, which is great. So what I want you guys to do for the next 10 minutes, so I'll let you go until like 3:30, to try rewriting this code for yourself. So line for line, word for word, you should be able to, basically after you're done with this, be able to write your own code that allows the computer to ask for what is your name, and then you put in your name, and it'll output like hello, your name. So and then it'll ask what's your favorite team, and it'll say like I like this team, and it'll tell you like, oh wow, I like this team too. So that's what you're going to be doing. So we're actually getting more interaction with the computer. We're getting more interaction with using strings and using the inputs. So just some notes that I want to make before I let you guys go. Again, like hashtag include string, you're always going to need it whenever you're creating these string variables. Again, you're using namespace because we are going to use like endl, or not necessarily, but like you can use endl instead of use \n. That's what I was talking about. Instead of \n, you can use endl to get it onto a separate line. And then this get line here, this get line function, allows you basically to get the line of a string that's given to you. So whenever you're using my string, cin, like basically says that we're going to be getting an input, and then get line is telling us that, okay, the input is a string, so let's evaluate what that string is. So yeah, I'll give you 10 minutes, so until 3:30. Figure it out yourselves. Try like basically creating this exact same program. And if anything, you have problems or you need help with anything, again, I'm always here.